Hey guys, what's up? Welcome back to today's video. Today, the video is going to be kind of different from whatever we have done in my previous videos. I used to teach you theory and all, but today I'm here to accept one challenge. Wait, I'll tell you what the challenge is. Remember last video I told you that there is this formula for steric number which is used to tell the hybridization, the shape and the bond angle of almost any molecule? Yes, you are thinking in the right direction. Today I have taken a total of 40 questions and I will be solving all these 40 questions based upon the same formula. I'll be putting a timer here so that I can see how much time it takes me to solve the questions. And I have one work for you, maybe a challenge for you. Whatever time it takes for me to complete all the 40 questions, I want you to break the record and to accept this challenge to solve all these 40 questions in less than the time I will be taking to solve the questions. Done? So are you ready to accept the challenge, Will be? I am ready to accept the challenge. I hope you will also be ready for the same. So let's quickly get started with the first question, which is BeH2. So beryllium I know is 2, 2. So half number of valence electrons of beryllium is 2 plus number of atoms attached by single bond is 2 plus no charge, so 0, so it comes out to be 2. And if it is 2, the hybridization is sp and the shape will be BeHH. If I take a picture, the shape appears to be linear, right? And the bond angle comes out to be 180 degrees. Done? Moving on to the second question, I have BH3. Boron I know is 2, 3. So half. Number of valence electrons 3 plus number of atoms attached by single bond 3. So 3 means sp2. And sp2 means, so hybridization is okay. sp2 means it should be something like this. If we take a picture, it comes out to be trigonal, planar, and the bond angle will be 120 degrees. Moving on to the next molecule, CH4, which is 2, 4. So half. Number of valence electrons, 4. Number of atoms attached by single bond, 4. So 4. That means sp3. sp3 means carbon in the center and 4 hydrogens like this. If I ask you to take a picture, this is tetrahedral and the bond angle we have done in last video is 109 degrees 28 minutes. Now moving to the next question, 3 questions we have done. We will do all the questions in a set of 3. Next is BH3. Oh, BH3 we did. Let us talk about CH3Cl. Let me talk about CHCl3. Let us talk about CH3 positive. All of them are carbon, so valence electrons is 4. Half. 4 plus number of atoms attached by single bond. So 3 hydrogens, 1 chlorine, 4. That means 4. 4 means sp3. sp3 means I have 3 hydrogens and 1 Cl. So the shape is again tetrahedral and bond angle is approximately 109 degree 28 minutes. Done? Moving to CHCl3, half. 4. Now 3 chlorines and 1 hydrogen. Doesn't make a difference. 4. 4 means sp3. Now 3 chlorines are there and 1 hydrogen is there. So again the shape is tetrahedral and the bond angle is 109 degrees 28 minutes. Moving on to CH3 plus, half. 4. Number of atoms attached by single bond, 3. It's plus 1. So be careful, it should be minus 1 here. So it comes out to be 3. 3 means sp2. sp2 means CHHH. Put a whole bracket because there was plus 1, so I'll be able to put plus 1 here. So sp2 means it should be trigonal planar, and since it is trigonal planar, the bond angle should be 120 degrees. Done? Let us move further to the next questions. we have CH3 minus CO2 and CO3 2 minus, all carbons, so 2 comma 4, half. We have 4, number of atoms attached 3, now it is minus 1, so I'll do plus 1. Similarly here half, okay, this will do later on, so it is 4. 4 means sp3, but be careful. Here the number of bond pairs are 3, so divide it like this. Bond pair is 3, lone pair is 1. So carbon, 1 is lone pair and 3 hydrogens with whole 1 negative charge, right? Now if you take a picture, lone pair doesn't come in the picture. So the shape is pyramidal and the bond angle is again approximately 107 degrees. Then let us move to carbon dioxide. 4 plus, don't write 2 here, don't write 2 here because oxygen gets attached by double bond. So we'll just assume 0. So 4 by 2 means 2, 2 means sp. sp means carbon in the center, 2 oxygens here. But you know that oxygen gets attached by a double bond, so put double, double. Take a photo, it appears to be linear and the bond angle is 180 degrees. Done. Let us move to CO3 2 minus, half, 4 plus. Again 3 oxygens, but I'll put 0. Minus 2, so plus 2. So it comes out to be 3. 3 means sp2. Done. Now see, 2 negatives are there. So put this O, O, O. 2 negatives are there. Put negative on any of the 2 oxygens and put a double bond. So this is carbonate ion. The shape is trigonal planar and the bond angle is 120 degrees. Done. So these were all the molecules with respect to carbon. Now let me see the list to write more molecules. We have NH3, we have NH4 plus, we have NO3 minus. Okay, let's continue. So nitrogen is 2, 5, so half. 5 plus 3, which is 4. 4 means sp3, but be careful. Bond pairs will be 3 because 3 hydrogens are here. And lone pair will be 1. So it should be N with a lone pair and 3 hydrogens. Okay, so the shape is pyramidal and the bond angle is 107 degrees. Done. Moving on to NH4 plus, half. Everything goes the same, 5 plus 4. But it is plus 1 here, so I'll do minus 1, which means 4. 4 means sp3. And then it should be N, H, 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 H. It's a plus thing, so put it in a bracket and put a plus 1 here. Now, if you take a picture, this is tetrahedral and the bond angle is 109 degrees, 28 minutes. Done. Moving further to NO3 minus, half, 5. Be careful, oxygen is there, so put a 0. Now, minus 1 is there, so plus 1, so 3. 3 means sp2, N. Wait for a minute. So 3 oxygens are there. Put 1, 2, 3. Now 1 O minus is there, so I'll put minus. Now we know that 1 nitrogen gets attached by double bond. But I told you nitrogen cannot form 5 bonds. So don't put a double bond here. And if I put a single bond, it doesn't work because oxygen will not be stable. Remember, we did, it forms a coordinate bond. Now I told you whether it is coordinate or covalent, doesn't matter. It looks to be the same. So the shape is trigonal planar and the bond angle is 120 degrees. So done with this also. Let us continue further. We have NO2 minus, HNO3 and HNO2. Again, all are nitrogen, so valence electrons is 5. So half. 5 plus 0 plus 1, which is 6 by 2, which is 3. 3 means sp2. Take a break. How many bond pairs and how many lone pairs? So 2 should be the bond pairs and 1 will be lone pair. So 1 lone pair, put 1 lone pair here. and one negative is there, so put one negative here and a double bond here. Now if you take a picture, only this thing comes in plane. So only this thing comes in picture. So this is bent or V or bent V shape. Done? Moving to HNO3, half. Do remember nitrogen is there in the center, so nitrogen will be the central atom, 5. Number of atoms attached by single bond is only 1 because it's hydrogen. So 6 by 2 is 3. 3 means sp2. Now this is something new which we have never studied. How to draw the structure. N in the center and 3 bonds to be done. Now, so how many hydrogen, nitrogen and 3 oxygens are there? Okay, so nitrogen you have done. Put one H and one O together. So let me put OH here. Done. Now we know that one nitrogen forms a double bond with oxygen. This is also done. And we know nitrogen doesn't form 5 bonds. It has to form one coordinate bond. So this O forms a coordinate bond. So this is the structure. And this is the most important molecule I'm talking about, nitric acid. Understood? So the shape is trigonal planar and the bond angle remains the same, 120 degrees. Done. Moving on to HNO2, half. Nitrogen is the central atom, 5. Number of atoms attached by single bond, 1. So it is 6 by 2, 3. 3 means sp2. But let's be careful. Nitrogen has to form these bonds, right? So I'll write now HNO2. Something like this. Nitrogen in the center. Now put one O and one H together. That's the thumb rule. O and H have to be together. OH. Now other oxygen will be forming a double bond. Understood? Let me write OH here just for simplification. So one is left. So I will put it as a lone pair. Now when this is the lone pair, isn't it the same shape? It was supposed to be trigonal planar, but because of one lone pair, it turns out to be bent or V-shaped. Done. These were all the molecules related to nitrogen. Now let us move on to other set of molecules. So we'll be taking, let us take water, let us take O3, let us take SiCl4. Fine. So water is, oxygen is the central atom, half. 6 plus number of atoms attached by single bond, 2, which is 4. 4 means sp3. But now be careful. How many bond pairs and lone pairs? Hydrogens are 2. So 2 bond pairs and lone pairs will be 2. So the shape was supposed to be something like this, but only 2 hydrogens are there. So convert it to a lone pair, convert this to a lone pair. When you take a picture, it is nothing but bent or V shape and the bond angle is 104.5 degree. This we did in previous video, right? Moving further to O3. Now see guys, there is a trick to how to find the structure of O3. Can I not write O3 as O2? That's the same thing, right? O3, I have divided it as OO2. Now let me consider this oxygen as the central atom. So if this is the central atom, half. Number of valence electrons, 6. Number of atoms attached by single bond, 0, because this oxygen becomes a side atom. And if oxygen is a side atom, it will not form a single bond. So I'll simply put a 0. So it should be 3. Now one thing is clear, that the hybridization has to be sp2. Understood? So now if it is supposed to be sp2, it should be simply like this. Now it has 2 more oxygens. So oxygen forms one oxygen, a double bond, O, double bond O, and now octet is complete. So it will form 1 as a coordinate bond. And this one is left, so put it as a lone pair. Understood? So see, O3 is written as OO2, half, 6 plus 0, 3. So out of 3, how many bond pairs are there? 2. How many lone pairs are there? 1. Put 1 lone pair, 1 double bond, and 1 will be kept as a coordinate bond. So the shape will be again bent or V-shaped. Fine. Moving on to the next molecule, SiCl4. Now silicon is 2, 8, 4. So number of valence electrons is 4. Number of atoms attached by single bond is 4. 4 means sp3. So the shape will be Si Cl, 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 Cl. Something like this. So this is tetrahedral again, and the bond angle will be 109 degrees 28 minutes. Done with this, let us move further to the next examples. So we have done this. Now PCl5, okay. We have PCl5, we have PCl4F, and let's take one more example, which is PO4 3 minus, okay. Now this will be kind of new thing which we are doing. Phosphorus is 285, so half 5 plus number of atoms attached by single bond 5. Now if it is 5, I told you last video, hybridization is sp3d, and if it is sp3d, it should be something like this and 2 Cls like this. So these 3 are equatorial, 2 are axials. So the shape is trigonal bipyramidal. Okay, I will not write trigonal bipyramidal again and again because it is too long. I'll simply call it as TBP, trigonal bipyramidal. Now an important thing, if we have to talk about the bond angle. So you look at this. They are forming a triangle. So the angle between these two bonds is 120 degree. Similarly, between these two and these two. So there will be 3 120 degree angles, right? Now you look at this bond and this bond, or this and this, or this and this. So there is a triangle in the plane and one bond is like this. So this is at 90 degree angle. So the 90 degree angle is also there. Moreover, if you look at Cl, PCl, this is a straight line. So the bond angle will be 180 degree. This is also very, very important to remember the bond angles here. Done. Moving further to PCl4F. So we have half 5 plus 4 plus 1. So 5 atoms are there. Again it is 5. 5 means it should be sp3d. I'll write this later on. It is sp3d. So it should be P this. Remember yesterday I was teaching you, or maybe in the last video we studied what is Benz rule. So Benz rule says that lone pair goes to equatorial position, electronegative atom goes to axial positions. I hope you watched the last video. Now fluorine is electronegative, so it has to go to axial, and all the chlorines can go wherever they want. And the shape is again trigonal bipyramidal. Done. Moving further to the next question. Wait a sec, let me remove it. So we have done this. Now let us do PCl3F2 and let us do PO4 3 minus. Let's first do this. This is a similar question. So half 5 plus 3 plus 2, which is 5. 5 again means it is sp3d. So it should be P trigonal bipyramidal. But you have to remember Benz rule again, which is electronegative. Fluorine is electronegative and 2 fluorines are there. So make them sit here and the 3 chlorines will come here. So once again, the shape is trigonal bipyramidal. We have done this, we have done this also. Done. Moving on to the next thing, PO4 3 minus half. Phosphorus is 5, number of atoms attached by single bond, oxygen is 0, plus 3 will be there. So 5 plus 3 is 8 by 2, 4. 4 means sp3. Fine. Now sp3 means it should be something like this. So 3 minus are there. So you put O minus, O minus, O minus, and you put a double bond here. Done. Take a picture. It simply comes out to be tetrahedral and the bond angle comes out to be 109 degrees 28 minutes. Done with this. Let us move to other questions. This is done. Now we have other set of questions, which is pH3. And let us talk about H2S. Now, if I am solving this video for these two questions, the video will be controversial because first let me solve these two questions. So, phosphorus is half. So, 5 plus 3 should be 8 by 2, should be 4. That means it should be sp3. So phosphorus in the center, 1 lone pair and 3 hydrogens, right? So according to CBSE, according to traditional teaching method, the shape should be pyramidal and the bond angle should be approximately 107 degrees, right? Now moving to the next question, which is H2S. Half sulfur is 6 plus 2, 8 by 2, 4. 4 means sp3, right? How many bond pairs? There will be 2 bond pairs and there will be 2 lone pairs. So the shape should be 1, 2 and these two. So if you take a picture, it should be bent or V-shaped and the bond angle should be approximately 104.5 degrees, right? So guys, these two questions that I have discussed here, these are traditional way of discussion of these questions. I am telling you both the two answers are not correct according to JEE and according to NEET. According to JEE and NEET, these two have no hybridization at all and these are said to be Drago compounds. So I will be making a separate video for Drago compounds. You can find the link here where I will be studying Drago compound. But if you discuss according to CBSE, according to traditional method, this is the correct answer. For JEE and NEET, knock knock knock, this is not correct. Understood? Now let us move on to the next examples. We have, so we did PH3. Now let us H2S we have done SF6, SO2, SO3. SF6, SO3, SO2. Let's discuss these three questions. So sulfur is 286, half. So 6 plus 6. This is another thing which we got, which is 6. So hybridization is sp3d2. And I told you last video, so it should be like this. So a square is formed and 2 pyramids are there. So this shape is octahedral. Some people call it as square, bipyramidal. And if I talk about the bond angles, this, or this, all the bond angles are 90 degree in the plane. If you talk about this and this, so one is in the plane, one is perpendicular to the plane, so bond angle is again 90 degree. But if you talk about this SF bond and the lower one SF bond, the bond angle will be 180 degree. So the two bond angles are 90 and 180. Done with SF6, moving on to SO3. Half, sulfur is 6 plus 0 because it is oxygen. So it should be 3, 3 means it should be sp2. And if it is sp2, it should be oxygen forming a double bond. Now other two oxygen will form a coordinate bond. Fine, because the octet cannot be expanded. Or if you want to expand the octet, you can also draw this structure. Both the two structures are valid. So the shape is trigonal, planar, and the bond angle is 120 degrees. Done. Moving on to the next question, SO2, half, sulfur is 6 plus 0, which is 3. 3 means hybridization for sure will be sp2. But now it has how many bond pairs? 2. Lone pair is 1. So the shape will be this, and 1 lone pair will be there. You have to remember sulfur can form double bond with oxygen, as many double bonds as sulfur wants. Okay. So if you look at the shape is again bent V or bent V shaped. Done. So this was about sulfur dioxide, sulfur trioxide. Moving to other questions. Let me note down 3 more questions. So I have SO4 minus, SO3 minus. Now let us do H2SO4 and one more I'll be doing. So sulfur is 6 plus 0 plus 2, which is 4. 4 means sp3 hybridization. So 1 sulfur and like this. 2 negatives are there, so O minus, O minus. Other 2 will simply form a double bond. Understood? So the shape is again tetrahedral and the bond angle is 109 degrees 28 minutes. Moving on to SO3 minus, half. 6 plus 0 plus 2, which is again 4. 4 means sp3. Now how many bond pairs and how many lone pairs? So let's see how many bond pairs and lone pairs are there. So if I talk about bond pairs and lone pairs, so the bond pairs are 3 and the lone pairs are 0. Okay, so bond pairs are 3 and lone pair will be 1 because 4 minus 3 is 1. So if I write, it should be S, something like this. So double bond O, how many O2 minus are there? So 1 minus, convert this to a lone pair. Done. The shape is again pyramidal. And the bond angle will be approximately 107 degrees. Done. Moving to H2SO4, half. Sulfur is 6 plus oxygen is 0 plus 2 hydrogens are there. So 2, which comes out to be 4. 4 means sp3. Now be careful, you write H2S1, 2, 3, 4. Write like this. So put sulfur in the center and 4 bonds like this. Now one O goes with one H, other H goes with other O, and sulfur is already there. Now form double bond with oxygen. Okay, so this is H2SO4. Again the shape is tetrahedral and the bond angle is 109 degrees 28 minutes. Done. So this is done. Let us move to other questions now. So one side of the page is over. Now let me just turn the page to get other questions. First I have written is H2SO3 and SF4. So these are also for sulfur. Half 6 plus 2 plus oxygen is 0, which is again 4, and 4 means sp3. But be careful, it is H2SO3. So H2SO3. How to do? Sulfur in the center. First draw the skeletal structure, okay? Now one H goes with one O, other H goes with other O, and we have one which is a double bond. Let me remove this. Put one OH double bond here, OH here, and this is the structure. Fine. So this is pyramidal. This is a pyramidal structure. Done. Now let us go to SF4. SF4 is half. We have 6 plus 4. Now this is 5. Oh, this is a new question. So 5 means the hybridization is sp3d. How many bond pairs and how many lone pairs are there? So we have bond pairs equal to 4 because 4 are there, lone pair equal to 1. Now it should be S, something like this, right? Now remember Benz rule. What Benz rule says? It simply says that the lone pair goes to equatorial position. So just make the lone pair go to this equatorial position. You can make it go here or here, but I feel like drawing it here. So you draw it like this, and this is the shape. Okay, now just turn it, tilt it, you will see as if it is a seesaw shape. So I'll simply write the shape to be seesaw. That's it. Done. This was about the molecules of sulfur. Moving further to other questions, we have ClF3 BrF5. Half. Chlorine is 7 plus 3 fluorines. So it is 7 plus 3, 10 by 2, 5. Again, I am very clear, hybridization is sp3d. Now, how many bond pairs are there? Bond pairs will be 3. So lone pairs will be 2. You need to take in account the Benz rule that the lone pair goes to equatorial position. So it should be Cl, something like this. 2 lone pairs. Now I will put 2 lone pairs here. And F, F, F. Understood? So this is a kind of T-shaped. Done? These 2 lone pairs do not come in picture. So the shape is T-shaped. Moving on to BrF5, we have half. 7 plus 5, which is 12 by 2, which is 6. 6 means it is sp3d2. And how many bond pairs? 5 F are there. So bond pair is 5, lone pair is 1. So you put Br, F, 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 F. Remember I told you that the Benz rule is applicable only and only for trigonal bipyramidal structure. Here all the bonds are same, so you can put the lone pair anywhere. Now if I talk about the picture, this is a square and there will be a pyramid from one side, right? So the shape is square pyramidal. Done? So this was about CLF3 and BRF5. Let us further do other questions. And we have XEF4, XEF6, XEOF4. XEF4, XEF6, XEOF4. So see, these are noble gas. Noble gases are also forming compounds here. Let us start with xenon. Obviously this is noble gas, so valence electrons are 8. So 8, I am talking about XeF4. 8 plus 4, 12 by 2, 6. 6 means sp3d, right? How many bond pairs are there? 4. How many lone pairs are there? 2. So it should be Xe. So it should be 6 means sp3d2. So 1, 2, 3, 4. Put 1f, 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 1f. Let us put one lone pair here and let us put one lone pair here. Now when you take the picture, only this picture comes, right? So this is square planar because there is a square in the plane of the paper. So this is square planar. Now moreover, all the bonds are in the square, so the bond angle will be 90 degrees. Understood? So this is about XeF4. Now let us study about XeF6. XeF6 will be half. 8 plus 6, which is 7. So this kind of hybridization is not there in CBSE, is not there in JEE. This is kind of, I should say, distorted octahedral. I just discussed it here to tell you that this is an exception, but the details we will be doing in a separate video for XeF6. Understood? Let us move to XeOF4. So we have half, again 8 plus 4. Oxygen is 0. 8 plus 4 will be 12. 12 by 2 is 6. 6 means sp3d2. So it should be, let me first draw. Now XeO, one oxygen forms a double bond and fluorine is there. And let us draw this as a lone pair. Okay, again this is a square but a pyramid is formed on the top. So the shape is square pyramidal. Done? So this was about XeOF4. Let us try to do a few more examples if they are there. I think I'm like close to 40 number now. Now we have XeO3 and I minus. XeO3 is half 8 plus 0 because oxygen gets attached by double bond. So this is 4. 4 means it should be sp3, but how many bond pairs and how many lone pairs? So bond pair has to be 3, lone pair will be 1. So it should be Xe, lone pair, double bond O, double bond O, double bond O. Understood? And the shape is pyramidal. And the bond angle will be approximately 107 degrees. Done? Now one very decent molecule which is I3 minus. So many times JEE and NEET have asked questions related to I3 minus. And there is a trick to solve the question. How to write I3 minus? You write it as I2 minus. Remember how we did O3? I had written it as O2. Similarly, I3 minus, I'll write it as I2 minus. Half. How many number of valence electrons of iodine? 7, because it's a halogen. Plus, iodine gets attached by single bond, so 2. Plus 1, that means 10 by 2, 5. 5 means sp3d. I hope this much is okay. Right? Now, how many bond pairs are there? Only 2 bonds are formed. And how many lone pairs are there? There are 3 lone pairs. Okay? So the shape should be, right? But the Benz rule says that the lone pair goes to equatorial position. So let me draw one lone pair here, one lone pair here, and one lone pair here. I'll put one iodine, whole with 1 minus charge. Now if I ask you to take the picture, only this thing comes in picture. So the shape will be linear and the bond angle is 180 degrees. Understood? This is the most important question from today's video, and you have to mark it as very important because this will be there in your exams. Done? Moving on to the next chote mote problems which we are having. I3 minus, let us do ASF5. First of all, you should know AS belongs to which group? It belongs to group number 15, nitrogen, phosphorus, arsenic. So I'll write half, 5 plus 5, which is 5, means sp3d. sp3d means AS F5. This is normal, nothing controversial here, and the shape is trigonal bipyramidal. Bond angle I told you is 120, 90 and 180 degree. That's also done. Understood? Let us now do another molecule, AlCl4 minus. Half. Number of valence electrons of aluminium 3. Number of atoms attached by single bond 4 plus 1, which comes out to be 4. 4 means sp3. So it should be Al, Cl, 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 whole bracket with 1 minus charge. The shape is tetrahedral and bond angle is 109 degrees 28 minutes. Done. Now moving to the 40th question, which is BF4 minus half. So boron is 2, 3. So 3 plus 4 plus 1, which is again 4. 4 means sp3. So B, F, 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 put the bracket with 1 minus charge. The shape is tetrahedral and the bond angle is 109 degrees 28 minutes. Stop. So guys, these were all the 40 questions, or maybe 41, I think. 1 or 2 extra might be there. So these were all the 40 questions that I wanted to discuss with you. Now I am giving you the challenge. You have seen the time it took me to complete all the questions. By the way, I was explaining you, so it took me a little more time, right? So now I want you to accept the challenge and try to do all these questions, or maybe more if you have, in time less than my time. Okay? So now, keeping the challenge aside, let me tell you the importance of today's video. Out of all the questions that I have discussed, for sure you will be getting 4 or 5 questions in every exam you write. Maybe you are writing your school exam, maybe you are writing JEE mains, you are writing JEE advanced, or you are writing NEET, you are writing SAT, any paper you are writing. These formula, like this formula and all these shapes and the molecules will be required. Okay, so thanks for watching the video. Try to accept the challenge and try to comment how much time it took for you to complete the challenge. Thank you very much. Bye-bye.